Hello, in this video we're going to be talking about finding the key points of a parabola when we are given graphing form, or sometimes it's called vertex form. So this is an example of a parabola when it is given in vertex or graphing form. It have the quantity being squared, so this is called a perfect square, and you have minus 16. So the vertex is the easiest thing to find, or the quickest thing to find when you're given something in that form. And what you do is you take a look at your positive 1 or the plus 1 that's inside your parentheses, and then you need to know the value that's on the outside, and you're always going to do the opposite of what you see here, so it becomes a minus 1, and then you just keep this value here. That's negative 16. So it's sometimes called the change the h, keep the k, so hk is negative 1, negative 16. From here, we're supposed to be able to find all the other key information, your line of symmetry, your x-intercepts, and your y-intercept. We know that x-intercepts are going to be something in the form of something 0, where your y value is 0. Most of the time, our parabolas have two x-intercepts. Not always, but most of the time for our examples, they do. And the y-intercept, you're going to have a 0 there, but you're trying to find out what the y value is. And once you know the line of symmetry, that comes from the vertex. And once you know the x-intercepts, you can find your factored form. So the line of symmetry, that one is quick because it's just going to be matching up with whatever your h is. And so there is symmetry around x equals negative 1. Based upon that, we're going to make a table. That is how we're going to find our other key pieces of information, doing it numerically and not necessarily algebraically by solving, although there are ways you could do that we're not going to cover in this video. So since you have the symmetry at negative 1, you're going to make a table, but it is important that you put that negative 1, negative 16 kind of in the middle of your table so that you have values to move on both sides. And then you're just going to figure out what's going on at 0, and then if you know that also helps you figure out what's going on at negative 2 because of the symmetry that exists. When you plug 0 in, you have 0 plus 1 quantity squared minus 16. Okay, well, plus 1 squared, that's just going to be a 1. And then 1 squared is 1 minus 16, so that's going to be a negative 15. Well, right from there, we know our y-intercept then, because that's going to be when x is equal to 0, like we said. So that's going to be 0, negative 15. That is your y-intercept. And because of the symmetry, you know that these also have negative 15 at that spot as well, because it's just on the other side. And you keep on going to figure out what's going on at a positive 1. So that'd be 1 plus 1 quantity squared minus 16. So that's 2 squared minus 16. And 4 minus 16 is a negative 12, which means at negative 3, you also have negative 12. Do the symmetry. You do the same thing for going on at 2. So that's 2 plus 1 quantity squared minus 16, or 3 squared minus 16. And that would be then 9 minus 16, which is a negative 7, which means at negative 4, you also have negative 7. We're getting closer. And then at 3, you do 3 plus 1 quantity squared minus 16, which is equal to 4 squared minus 16. And you can see now kind of this pattern that's occurring, 2 squared, 1 squared, 2 squared, 3 squared, 4 squared, as you move away from that vertex. 4 squared minus 16, that's equal to 0. So that means that negative 5, that's also equal to 0. And there you can now see you have your two x-intercepts. They're going to be at negative 5, 0, and also at 3, 0. And that is how you can find those key points just by using a table, essentially plugging in a bunch of values to find out what those points are. And additionally, once you have your x-intercepts, you can actually go ahead and find your factored form as well. If you know that you have an x-intercept at negative 5, that must come from a factor of x plus 5. And if you have a factor of 3, that comes from a factor of x minus 3. And there is a 1 out in front of this whole thing, so there's your a value is 1. Most of our problems, that is going to be true for these example problems.